Please provide a brief work background and describe your current role with Bentley.
Hello, Todd. Good afternoon. So, just to give you a little bit of my background with Bentley and a little bit of what I have done in the past. So, my background is actually with Legion. I actually came to Bentley via the acquisition of Legion, which is a company that has always focused on the simulation of people movement over the years. And since I joined Bentley, I actually passed through a few roles. So I worked in business development, and then now I'm actually managing one of our product lines. So the brand is Open Buildings inside of our design integration team. And that brand includes all of our design applications. So all of our BIM multidisciplinary platforms like Open Buildings Designer, Open Buildings Station Designer, but also the simulation applications around those platforms. So people movement simulation with Legion, and also energy simulation, facilities management, and a few other applications under that brand.
Describe Legion Simulator. What does it do, and what was its original purpose for design and engineering?
So Legion Simulator is an application, as I mentioned before, to simulate human behavior associated with movement. So it's pretty much to understand how people behave as they go through different types of spaces. And the way we did it is actually many years ago, around 20 years ago, when we originally built the tool, we went to different places around the world, so different train stations, airports, stadiums, and we collected data about people movement. So we filmed people to understand the speed that they walk, the way they behave, and how do they approach each other as they are walking towards each other, but also how do they approach stairs, escalators, and different types of activities inside of space. So with that data, we created profiles that are actually the baseline of that simulation, and that pretty much enable a designer or an engineer to go and test their design from very early stages, like conceptual design of a building, all the way through detailed design, construction, and later on operation of that building.
So how can it now help companies design for social distancing? Did it have to be changed at all for this purpose?
Very good question. So in terms of social distancing, it's a very good point. Social distance can actually be characterized as a disruption. And of course, as we know, the disruptions have actually been growing. It's a big trend today in terms of infrastructure. Over the past couple of years, we have seen technological disruptions that have impacted quite a lot of our different infrastructures like stations. So if you get the example of taxis, like for many, many years, a designer thinking about a station would only design it for one taxi rank, whereas nowadays we just use mobile apps to call for our cars to actually pick us up in stations. So it's a big change. It's actually disruption, changes the way we operate those stations. So social distancing is very similar. At the end of the day, what we see in terms of operations of stations today around the world, or as we start to reopen some of the public transports around the world, the main requirement there is for users to avoid exposure or time that they have close to other passengers. And what can be done with simulation is actually testing all those different scenarios before we implement any control strategies. Those strategies can be either infrastructure strategies like barriers, like queuing systems, but they can also be soft measures like stickers on the ground showing people where to stand, or staffing of those stations and how to make sure that people know how to social distance, which is not a natural human behavior. I think part of the question is if we change the software. We haven't changed it yet because we don't know yet if that behavior will be a sustained behavior in the future. So we need to understand first how long will it take for people to go back to the new normal or to adopt that new normal, or to go back to the behaviors that they had before. So as soon as we understand that, then we will be able to collect new data and to create this new pattern or create this new type of entity. But until then, simulation is still very powerful and can still help a lot of owner operators to actually reopen for the public.
Can you walk me through an example of how it would be used?
So over the years, as many owner-operators have been using Legion, so the original application of Legion, or one of our original users, was Transport for London, with the application of Legion for a lot of the London Underground stations in the City of London. So not only for greenfield projects and new stations, like we had the example of Crossrail just recently in the UK, but also for refurbishment and adaptation of some of the existing stations. So either with projects to reduce congestion or to make those stations safer, or to future-proof those stations into the new technology, new trains that they are adopting, reduce headways, and of course the increase of demand that they have. So there are many examples of those stations. So if you get any of the large stations in the City of London today, like Bond Street Station, Bank, both of them just London Underground, or if you get some of the overground stations as well, like London Bridge, Waterloo, or Victoria, all of them have passed through very similar processes of creating a base model, identifying which changes would actually improve the flow of passengers inside of those stations, and then delivering those projects effectively using Legion. So many of those examples, like Bond Street Station, they never stopped operating the station during those changes. And by using Legion, by using simulation, London Underground actually increased the capacity of that station by 30%, for instance, without actually doing that all based on computer simulations using Legion and Open Building Station Designer.
So what is unique about Legion that can't be done as well or easily with other solutions?
Sure. So one of the differentiators of Legion, as I mentioned earlier, is the fact that we actually collected real life data around the world. So we installed cameras in different types of infrastructure to actually understand how people behave. And we created these profiles that you can actually choose when you're building your simulation. So that makes Legion one of the most granular and microscopic level simulation tools in the market. Which is pretty much the best way of identifying different types of entities and different types of passengers inside of a station, for instance. So if you get the example of AREP, there's an SNCF subsidiary in France. Whenever they're looking to some of their stations, like Gare du Nord in Paris, they can go to the level of understanding how does a wheelchair passenger journey through the station is going to be like. So how long does it take? How crowded was that journey? Even how many signs did that passenger see when they were going through the station? And all of those questions are very difficult to be answered if you are abstracting people movement or all the different entities and comparing them to either gases or liquids, as social forces based simulation tools are actually doing. So Legion is very granular. And of course, it has also been validated and calibrated over the years scientifically and by a lot of these different users.
Can you share some user feedback on how they've been using Legion and how it has been effective?
Sure. So we have been, of course, talking with quite a lot of our users over the past couple of weeks and months around social distancing as one of the disruptions, as I mentioned before. So that is definitely an interesting topic at the moment. We have a few talks also shared in some of our pages. But one of the great examples, for instance, is Atkins, that is now part of SNC-Lavalin. And they have actually done quite a lot of work supporting different governments and different owner-operators around the world on how to reopen their infrastructure. So if we get the example of train stations, they delivered a whole best practice guidance on how to effectively reopening those stations. And of course, a big part of that is actually using simulation. So it's actually testing existing stations or testing new projects like they have done just recently, or they're finalizing actually doing now with the Riyadh Metro in Saudi Arabia. There's a completely greenfield project where they use simulation to test all these components that I mentioned earlier. So the safety aspects of a station. So how long does it get to evacuate that station in the case of an emergency, or how long does it take, or even like social distancing aspects in terms of safety, right? But also efficiency of that station. So making sure that the space is enough, but is not too much. So making sure that that station is comfortable and it's accessible for the different types of passengers. And the third application, that is alternative revenues and making sure that all the shops and other activities in that station are viable and are actually working very well together with the other main purpose of the station, that is transportation.
So, what general advice would you give to engineers as they now try to design for social distancing?
So this is a very interesting question about the future of engineering. So and we actually just had exactly the same discussion in the past couple of days. So it's as I mentioned earlier, it's very difficult today to predict how much will this new normal be part of our lives in the future. Of course, that will depend quite a lot in us having a vaccine or a way of controlling COVID. But also the second question is, will social distancing become a new norm, a new behavior? And the third question is probably, will that behavior be the same in different countries or in different cultures, or is it something that will be very localized and that we'll have to learn how to deal with? So I believe the best advice here in terms of designing new infrastructure, of creating new projects, is definitely to create those projects based on digital twins. So we at Bentley believe that the future of infrastructure is actually the digitalization of that infrastructure. And then if we think about stations specifically, digital stations are actually resilient stations. So if we use all that data during the design process, either conceptual design or detailed design, then we take that data into construction, and then we move that data on into operation. We can use all that data in each single step of that life cycle to create simulations. And then, of course, it's much easier, it's much safer, it's much cheaper to run hundreds or thousands of scenarios of simulation in a computer than actually doing that in real life and taking the risk or the cost of doing that. So we believe that simulation actually saves time and helps us delivering much more out of the infrastructure that we are building. So that is probably the best advice for the future. Is we need more data specialists, we need more data scientists in our industry, and for sure we need to be more digital. We need to give the access to the right people of the right data at the right time.
Okay, obviously, no one really knows the answer, but where do you think, how do you think this is going to affect everything 5 years from now in design?
So it's as I mentioned before, it's a little bit difficult to predict. I think even COVID and social distancing came, even though some people predicted that over the years, it was very difficult to predict how much will that affect the world. But at the same time, one certainty about the future is that, in terms of infrastructure at least, is that it's going to be digital for sure. As we accelerate the development of our automation tools in every front, pretty much of our lives, but in terms of software development, definitely we are looking to automating design processes and automating routines. So the way we see the future is, if you start building that digital twin from very early stages in your asset life cycle, you're actually, which pretty much goes hand in hand with the adoption of BIM in the case of building, so building information modeling. So with all that data that you have created throughout the life cycle of that asset, you can actually make that asset better. It's much easier to track that asset operation, to simulate different future scenarios like energy consumption, people movement, safety, even structural engineering aspects of that building, and many other aspects that can be simulated and ran with that data. So we do believe that it's a digital future, and of course a big part of a digital future is also collaboration. So I believe not only in the future, but also today, I think with social distancing and quarantine, we are all working from home. We're all using quite a lot of the different tools that are available in the market. And Bentley also has an application in that market, that is ProjectWise 365, that we are also making available for free until the end of September. That is pretty much enabling engineers and architects and designers to work together remotely and to effectively collaborate in projects. So definitely the future of design is digital, is collaborative, and is, again, as I mentioned earlier, it's by having the right data at the right time for the right person.